Guess we'll go ahead and get started here. Can everybody hear me? Yes. I'm John Stewie. I'm the co-chair of the server project for OCP. My co-chair, Simac, is in the other room doing a lot of the Microsoft submissions, so we have 2 rooms for server. The server project has calls once a month on the 4th Wednesday. All the stuff is on the wiki out there. If anybody that needs more information, it's all out on the wiki. Go ahead and get started off. We do have a full schedule today. First up, we have Al Yanis, President and Chair of the PCI-SIG, talking about delivering bandwidth for OCP. Thank you.
Your mic just shut off.
Did it get turned off on the pack?
All right, can you hear me now? All right, thank you. So this slide, just want to point out we're 750 members strong. So I think there's still strength in numbers, ability. If you're a member of the PCI-SIG, you have a ability to collaborate. And if you're not a member, you can join us. And there's a lot of member companies, very healthy organization. PCI Express 4.0, I think everybody's aware, we delivered that 16 gigabyte for transfer in October of 2017. So we've seen some good, healthy adoption from our members, and we're working currently on the compliance suite. So this year in 2018, we'll have the integrators list for PCIe 4.0. So I want to hit a little bit of the topics there in 4.0, some of the changes that we enabled. The first one is lane margining. The scope guys really love this one. It's ability to figure out how close to the margin you are. 16 gig is obviously challenging, and you want to know if you're close to the edge, or how much margin you have to the edge. So it's a great, healthy debug tool. A couple of the enhancements that we've made in the protocol allows us to support 5.0. So we've extended the tags. So these are outstanding tags for read completions. We support up to 1,024. And also the flow control credit. We've scaled and created some new abilities to send greater size packets, right? As you go to faster speeds, you want to be able to have bigger packets. So, and this kind of stuff leverages us to enable 5.0. As I mentioned, a lot of adoption within our member companies, a lot of demos. I think it's public information. IBM has 4.0 announcements, and if you, and I think they even have something on the demo. And if you look through the, Google, you'll see a lot of member companies with press releases on 4.0. And I think some of the OCP members have some ability to demonstrate 4.0. On the electrical side, and really it's all about electrical these days, the 16 gig and the 32 gig. So currently for the rule of thumb for 4.0 is 45 dB loss channel. I'll go a little bit about what we're doing with 5.0 in this area, but that's kind of the target, and I'll give you a little bit of a breakdown. And the distance is going to be 12-inch for a 1 connector solution. So 4 inches on the add-in card and 8 inches on the motherboard. And if you want to go further than that, you're going to need retimers or a better PCB board technology. Like a Mectron 6 is one of the ones that some of the member companies are considering for if they don't want to use a retimer instead of FR4. So, I mean, it's kind of cool, the ability that we have in the SIG especially for the chem add-in card, the ability to be backward compatible. So you can plug in a 4.0 and in the future a 5.0 into the same slot that supports a 3.0 or 1.0 or 2.0. So we got this great choice, right? You can go wider for bandwidth, or you can go faster on the clock frequency to improve your bandwidth. So really a smorgasbord of options for you. So on the traditional 2.5 and 5.0 gig solutions, we had the 8-bit, 10-bit encoding. And really an innovation that we came up with was when we transitioned to 3.0, we went to the 128-bit, 130-bit encoding. And that allowed us to not have to go to 10 gig, but just to go to 8 gig to achieve our doubling of our bandwidth. Another item that we've done over the last couple of years that I think has been a great innovation is L1 substates. Not too many people are familiar with the fact that we have PCI Express on handheld devices. So there's several wins because the L1 substate solution that the protocol team has come up with basically drives idle power to essentially zero. And there's been several studies out there that shows that if you transmit data very fast and then shut off power, that is more efficient power-wise than sending lots of data very slowly and not ever getting to the shut-off state. This is just kind of a breakdown a little bit. I don't want to go through all the numbers, but essentially how we come up with 45 dBs for the 4.0 solution. And as I mentioned earlier, the target for 5.0 is going to be 35 dB. And how you get there, we'll have a channel that I don't have that today because we're still in development with 5.0, but we'll have a suggested channel for 5.0, and then it's up to you as the implementer or solution provider to either come up with a better loss channel or a better PCP material or retimer or different solutions that you can come up with to achieve your targets. Form factors, these are the sort of the sweet spots for us in the SIG that we support, the form factors that we support. We have the easiest one really, the ball grid array, chip-to-chip connection, so there's no connector, typically on the same motherboard. So this will, obviously you can achieve 16 gig or even in the future 32 gig a lot easier since you don't have the connector impact. M.2 is our smallest form factor. It's essentially for like laptop solutions. It's different sizes and different width and volumetric sizes, but it's obviously a very popular solution for folks that are constrained physically. U.2, primarily for like NVMe solutions, and it's very, very popular. It used to be called SSF 8639. And then we have the traditional CAM add-in card, the one I talked about for mostly like servers, and maybe some of the high-end desktops, where you can plug in and be backward compatible. So that's our traditional server 25-watt solution. A lot of folks have been asking for SRIS, which is essentially an ability to have a connection without a clock. So the traditional solution for PCI Express before 3.0 and this ECN got built or generated was the fact that you need a common clock for the root complex and let's say the device. But with SRIS, you have the ability to send data without the clock. And what folks are liking this solution for is for cable solutions. There's a lot of requests to not have to route a clock through the cable. But currently, it's just an optional feature. I highlight some of the challenges with implementing SRIS. The biggest one is the elasticity buffer. You have to have bigger buffers to compensate for the fact that you don't have a common clock when you're transmitting the data. So if you want this support, you need to sort of negotiate with your root complex or your supplier to make sure that they support SRIS as well. But we do believe that for some cable solutions, it'll provide a cost advantage. RAS features, just kind of highlight the fact that because some folks forget, we have end-to-end CRC protection. So we have the ability to send a packet and really enterprise server quality, so you can have the CRC route with the data through switches, through retimers, and comprehensively make sure your data gets there correctly. And we still have hot plug support, but it's the safety hot plug support that I would call, not the one where you can just yank something and maybe have a safety violation. So this is the ability to go up to a prompt or a terminal, shut off power, unplug the adapter, plug back in a new adapter, and enable power. So it's the traditional hot plug support. We have advanced error reporting. So if you have a PCIe solution and you care about sort of debugging things or maintaining good, robust air handling, you need to support advanced air handling. It's a bunch of new features that are optional, but really enables you to have a robust system, especially when something goes wrong. You have more diagnostics or debug capability to figure out what went wrong. It would be remiss of me to talk about the popularity of PCI Express without talking about NVMe. It's been really a great boost for the popularity of PCI Express. Primarily in the storage space, obviously. These charts are about 2015, but we talked to some of the analysts yesterday, and they really they're a pretty accurate projection in the future, and we'll get the updated slides here the next couple of weeks. But NVMe has been really popular and really eating into the traditional SAS space. They still think that SATA will still be around for low-cost solutions, but NVMe and the curve and the trend is still continuing as well. So 5.0, we announced this in June of last year, 32 gig NRZ. A lot of momentum, a lot of excitement within the organization. And as I monitor things within the work group and I'm on all the reflectors, they just had a face-to-face last week. I haven't seen so many face-to-face meetings within the group in quite a while. Primarily, we're targeting speed. So as I mentioned earlier, the protocol is kind of already in place. And there's been a desire, a need, momentum to get 32 gig as soon as we can. So 4.0 was a little bit late, but 5.0 I think we're going to be real fast. So we're targeting first half of 2019 for this spec release. I'll walk you through some of the other details. And I think I missed the keynote yesterday, but I think one of the keynote speakers was talking about 400 gig Ethernet, and which is exactly one of the areas that we were primarily targeting when we started the 5.0 initiative last year. Obviously, I'll have a couple of slides here about accelerators and the need for higher bandwidth for accelerators, and that's kind of understood. I mentioned L1 substates because that will continue to continue. So that's our handheld target, very volume-centric option for us. This is a slide we got from the Ethernet Alliance talking about 400 gig, but you guys heard the keynote, so I don't think I need to sell you on the need for 400 gig. This is a slide that I grabbed from last year's Olympus project, and I just kind of wanted to show you this is last year's slide. Those blue links are PCI Express, and guess what? They're running 3.0. They go PCI Express to the switch 3.0, and from the switch to the GPU, and they're all 3.0. So we released 4.0 last year, so they can easily go to 4.0. And now we're already working on 5.0, which will be spec released next year. So it really kind of encourages this project and other projects that you can invest in PCI Express, and you're enabled for the next several years and next several generations of speed bumps and enhance. Basically, this system here can quadruple the bandwidth going to the GPU. So the near term, as I mentioned, first half of 2019 is our target. The 0.5 spec was released in fourth quarter of 2017. Next month, we're targeting the 0.7 release. So like I said, we're going fast. Now, I wanted to highlight some of the items that the work group is working on just to give you a feel, like I said before, the target is currently 35 dB. It may change, but that's what the goal is. The connector, right? It's all about the connector. I think I'm talking to the right group here, since OCP is very connector focused. The connector is challenging, and especially for the chem card that we have, to make sure that the connector is backward compatible and also very sensitive to the 32 gig. We got some pre-encoding that we're going to add to the packets to reduce the types of errors that we can get. Number of DFP taps. This is a big hot item. You know, is it 3 DFT taps? Is it 4? Is it 5? That goes into how big your PHY is and also the power of the PHY. So it's a big deal for at least establishing a baseline. The electrical idle and electrical exit out state, the pattern is going to change, different sequence, but that's really kind of falls off the log. One of the reasons the way we think we can hit 32 gig so fast is the fact that there's already 28 gig and 56 gig solutions out there. So there's a lot of knowledge learned already that we can leverage. That's part of the how we get there so quickly. I kind of want to just walk through some of the numbers, make sure everybody's familiar with the math. This is the math, basic math here. 400 gigabit Ethernet is gigabit, so that's 50 gigabytes per second. Ethernet is full duplex. A 32 gig PCIe 5.0 solution by 16 will deliver 64 gigabytes. And 64 gigabytes will be able to saturate the 400 gigabit Ethernet NIC. And when I say 400 gigabit Ethernet, that could also be a dual 200. There's lots of ways that the 400 gigabit card solution can be built. The PCIe 5 variations of frequencies. The way I like to think about it is PCIe 3.0, a by 1 is 1 gigabyte. So if you go wider, you start multiplying. If you go to 4.0, you start doubling. So a PCIe 4.0 by 1 solution will be 2 gigabytes. A PCIe 5.0 will be 4. A by 16, you multiply 4 by 16. So this is kind of how you figure out quickly and easily the gigabytes and the width that you're going to need. This is my last slide. This kind of shows the history, and I was just talking to Roger, and he was the chair of the SIG back in the beginning. This is our 25th year anniversary happened this year, and kind of lays out what we've accomplished over the last 25 years as an industry and as a consortium in the PCI-SIG. And essentially, if you plot out all the math here, that essentially we doubled I/O bandwidth every 3 years, and we're on pace to do that with 5.0. Now, granted, we were a little bit slow in 4.0. Agreed, but we're back on track with a 5.0 solution. So let me check the time here. So we got about 5 minutes. I'll open up to any questions.
Anything you can say about C6 and where that fits in?
Yeah, C6 is not part of the PCI-SIG. We've had discussions with C6, and I think everybody's familiar that my familiarity is that it's 25 gig and it runs PCI Express, and it's got a coherent protocol. But right now there are different organizations out there. C6 is one of them. OpenCAPI, Gen Z. Everybody's sort of coexisting, if you will.
Any details on latencies Gen 5? Are they improving?
Well, I think by definition that's going to improve, right? Because you're not only are you running the interface at a faster clock, your internals are going to have to go faster, right? These 5.0 solutions are not going to be built in 28 nanometer technology. So I think there's a natural latency improvement related to just the faster clock and the internal plumbing going faster. but there's nothing necessarily in the protocol that we've done to improve the latency. Like I said before, part of how we get to 5.0 so fast is we're really focused on speed. So we don't want to distract too much with protocol changes. Yep.
Yeah, will there be any, SIG endorsed PCI Gen 4 cables, connectors, things like that? I know there was like Oculink and things like that in the Gen 3 space.
Sure.
SIG going to be addressing cables and interconnects?
Very, very good question. Yes, we still have Oculink. I think Oculink is currently working on 4.0 solutions. So I think Oculink right now only runs 3.0, but they are working on 4.0 solutions. And we have our traditional enterprise cable, and that's also going to 4.0. But we haven't seen a lot of adoption on the PCI Express enterprise cable. And Oculink has been, not as much adoption as we were hoping for.
Do you see other connector types entering into that, or is it going to be just, if you can meet the insertion loss, then you're fine? Is there going to be like a standardization of connectors to be used?
Not that we're working on, but should the industry have a standardization? Probably. But we're not working on anything like, in that realm. Sure.
Missing link electronics. We use PCI Express for embedded systems as a very fast local LAN. We're using non-transparent bridging. Is this becoming part of a standardized approach?
Okay. So when you say non-transparent bridging, you're using a PLX switch or root to root. Okay. And your root complex provider provides peer-to-peer then, or?
Not yet.
Okay. No, we haven't. I'm not familiar with anything in that realm, but we're 750 members. You're a member company, right? Can you send a suggestion to us or to myself and propose something, right? I get this a lot of feedback. Folks complaining about we're not doing this, we're not doing that. Hey, you're a member company. You don't. If somebody's not a member company, maybe can complain. But if we're a member company, reach out to myself. Reach out to David Harriman, who's the protocol chair, and make a suggestion.
Hi, thanks for your time. We're having trouble finding a clear specification for auto detect of ref clock versus SRIS
Okay.
and SRS versus SRNS.
Sure. There's been several. I brought it to the email reflector, and I see 20 emails on this topic. So I think that everybody's still trying to figure that out, is my read on the email reflector discussions.
Yeah, because the hard part is unless it's specified clearly, then all our PHY and front-end IT providers don't have a way to implement
Sure.
something that we can leverage.
I agree.
So is there a way how can I escalate that within PCI-SIG?
You can. I can give you a name, and I'll give you my contact, and we'll get you in contact with the protocol chair. All right. Thank you for your time.